In this video, we're going to continue our work with square roots. And I want to go back to when we were first graphing. When we were first graphing, I said quadratics represent lots of different things in real life, like objects falling or being thrown. All right, so when we graphed, we were able to find the vertex and the axis of symmetry of any graph. And this is important because this vertex, when objects are thrown, gives us the maximum height. Or if we had some kind of shape that looked like this, we would be able to find the minimum height using the vertex. Well, now I want to focus on what about this point here when it hits the ground? What happens when that object hits the ground? That means it's the graph of the parabola is hitting the x-axis. So this is what, remember, we call the x-intercept. So when we solve quadratic equations, we're always saying, okay, let's say this is y equals, this is the shot put one. So y equals this equation. Well, I want to know, when is this equation equal to 0? So I want to be able to solve that equation and find, where does that shot put hit the ground? That's important. All right, so let's talk about solving quadratic equations. There's lots of different ways we can do that. And first I want to talk about taking square roots. This should be a reminder from Algebra 1, but technically a positive number has 2 square roots. The square root of 9 is equal to positive 3 and negative 3. And the reason why is because if you turn around and square both 3 and negative 3 each time, you get 9. So if I do 3 squared, that gives me positive 9. And if I do negative 3 squared, you get positive 9. So don't forget, you're doing negative 3 in parentheses. It's not the same thing as doing negative 3 squared. If you did this on your calculator, it would give you negative 9, because your calculator would square the 3 first and then multiply by the negative. That's not what we're talking about. We're talking about taking a number and multiplying it by itself. This means negative 3 times itself, right? This does not. All right, so since a square root has 2 different numbers for its answer, when we are squaring both sides of an equation, or sorry, not squaring, square rooting each side of an equation, we have to keep that in mind and write both answers. So for example, if I had the equation x squared equals 9, and I want to take the square root of both sides, remember the square root cancels the square. So that helps me get the x by itself, but when I do the square root of 9, this x could have been positive 3, or it could have been a negative 3, and we write it as plus or minus 3. All right, so let's talk about solving. We are going to use the same strategies that we use with solving a linear equation, but here we're going to get the x squared part by itself. So like in this red equation up here, the x squared was already by itself. And then we do that so then we can take the square root of both sides. And that's so we can undo or cancel or do the inverse operation of the x squared. So let's look at some examples. We're going to do lots of examples. All right, in this first one, number 10, I have the x squared already by itself, so I'm going to square root both sides. So that gives me x equals plus or minus, the square root of 81 is 9, but I have to put plus or minus 9, because I have both positive 9 and negative 9. All right, same thing here. The x squared is by itself in number 11, so I'm going to square root, and I get x equals plus or minus the square root of 50. Now 50 is not a perfect square. However, we can pull that apart. Remember, we did that in the last video. So I can pull this apart into the perfect square of 25 times 2. So this is going to be equal to plus or minus. The square root of 25, that's just 5. And then the square root of 2 stays the square root of 2. So I have x is equal to both the positive and the negative 5 square root of 2. That would be our final answer. Moving on. So number 12, the x squared is not by itself. I have to get rid of the plus 1. So I'm going to subtract 1 on both sides, and I get x squared equals 12. So now that I have the x squared by itself, I can square root both sides. So I'm going to get x equals plus or minus square root of 12. Now 12 is not a perfect square, but we can pull that apart. and we can do the square root of 4 times the square root of 3. So x equals plus or minus, the square root of 4 is plain old 2, and then the square root of 3 stays the square root of 3. So that's our final answer on that one. In number 13, we have a lot of things that we have to get rid of before we start square rooting. So I have the 7 and the 2 on the same side as the x squared. So I need to cancel the 7 first. So that's going to be 2x squared equals 24. And I'm still not done. Don't square root at this point. I need to divide by 2 first. Now I've got x squared all by itself. So now I'm ready to do the square root part on both sides. And so I get x equals plus or minus square root of 12. And we already pulled that apart, so we know what that looks like. That's plus or minus 2 root 3. So we happen to get the same answer on both 12 and 13. All right. So try number 14 by yourself and pause the video, see if you can do that. Okay, so on number 14, you should have gotten x equals plus or minus square root of 5. And this is my work that shows that. Notice that I got rid of the minus 1 and the 3 first before square rooting. So make sure you did that. Number 15, we have that fraction. Don't let that fraction scare you. I still have to subtract the 1. So I have 1/3 x squared equals 6. And then I have to get rid of that 1/3. So you can think of it as I'm dividing by 1/3 on both sides. Or remember, dividing by 1/3 is the same as multiplying by the reciprocal, 3 over 1. So you can think I'm multiplying by 3 on both sides or dividing by 1/3. Either way, you get x squared is equal to 18. So now I'm ready to square root both sides. And then I get x equals plus or minus square root of 18. Now 8 square root of 18 is not a perfect square, so let's see if we can pull that apart. So I'm going to break that up into the square root of 9 times the square root of 2. Okay, so I need to write this over here. I'm running out of room. So then I'm going to get x equals plus or minus, let's see, the square root of 9 is 3, so that's just plain old 3, and then the square root of 2 stays the square root of 2. So that would be my final answer on number 15. All right, so now let's look at these down here. These look a little different because they have parentheses. All right, now I know your initial reaction to this is probably to write out the parentheses twice and square it. You can do that, but I'm going to show you an easier way. Remember that a square root cancels a square. So the part that's being squared, this whole thing is being squared. So if I want to undo the square, I can do the square root on both sides. So the square and the square root cancel, and I still have x plus 3 on the left-hand side. Over on the right-hand side, I have both positive and negative square root of 5. Remember, once you take the square root, you need both of those answers. But I don't have x by itself now. I still have to get rid of that 3. So I'm going to subtract 3 on both sides. And now I can't do square root of 5 minus 3 because the 3 is not underneath the square root. So I'm going to write it like this. I'm going to write the negative 3 first. And then that negative 3 is going to be both added and subtracted. Or the square root of 5 is going to be both added and subtracted. So I have two different answers. If you wanted to get decimals, you could do that. You could do negative 3 plus square root of 5 on your calculator. That would give you one decimal. And then you could do negative 3 minus square root of 5. That's the other decimal. Okay, so that's what that answer really means. So let's do another one like that. Now in this example, the parentheses is not all by itself. So what's being squared is not by itself. I have that 2 in front. So I need to get rid of that 2 before I square root anything. And do not distribute that 2. That's a big no. Don't do that. So we need to get rid of that. We're trying to undo things, not make things more complicated. All right, so I'm dividing by 2 on both sides, so that gets rid of the 2. So I have x plus 5 quantity squared equals 16. Now I'm ready to square root because the parentheses is by itself. So I can square root both sides. That cancels the square and the square root. So I have x plus 5 is equal to plus or minus square root of 16. Now 16 is a perfect square. So I can actually take the square root of 16 and get a whole number. So let's do that. Square root of 16 is 4. So I'm going to have x plus 5 is equal to plus or minus 4. So we got one more step. We've got to subtract that 5 on both sides. So now here, I can actually combine these together. I'm going to have a positive 4 minus 5, and I'm also going to have a negative 4 minus 5. I have both of those things. So since they're both not underneath the square root, I can actually figure out what that is. So 4 minus 5, that gives me x equals negative 1. And then negative 4 minus 5, that gives me x equals negative 9. So I can actually write out my two different answers there, just like I could over here. It's just we tend to, over here, leave our answer like the one in blue. But the green ones are okay too. So we're going to do more practice with that in class, but that's how you can solve a quadratic equation by taking the square root on both sides.